Alright, hope everybody's enjoying their evening. Wanted to record a video. This is problem number 2 on free response for stats. It says a hunting team notices that there was an overabundance of deer in a certain area. They wonder if deer prefer the food supply in that area over the surrounding areas. There are 3 types of grass areas in the forest where the hunting team goes looking. The proportion of acreage in each habitat was determined. Using an aerial survey, they were able to observe the deer. The question is there evidence, significant evidence, that the deer prefer a certain area? Assume the conditions are met. So, this is going to be a chi-square goodness of fit test because you're comparing one categorical variable location to the expected distribution. Now, if the deer did not prefer one area over the other, we would expect that however much acreage there is, like 28% of the acreage in habitat 1, we would expect 28% of the deer to be there, 43% in habitat 2, and 30% in habitat 3. Unfortunately, we may or may not have that, and that's what we're going to check. So we understood this chi-square. We're going to do the hypothesis. So the null hypothesis is that the deer sort of follow expected distribution based on acreage in each habitat. And the alternative is deer do not follow the expected distribution based on acreage. So we named the test, we identified the hypotheses. The next piece is the conditions. It says assume conditions are met. Remember, the conditions are random, independent population 10 times the sample. Random independent populations 10 times the sample. And you don't have to write this, I'm just writing it so you all know. And expected counts are greater than or equal to 5. So now we want to make our expected table. Habitat 1, 2, and 3 will make this expected. And let me do observed in a different color. So let me do observed over here. This is observed. So what did we observe? Well, we observed 50 deer in habitat 1, 40, and then 10. And expected, well, there's 27.5% of the acreage is here. There's 100 total. So this is 0.275 times 100, which is equal to 27.5. The next one is 42.5. And the last one is 30. So expected, observed. So that was step 2 was the conditions. Now we got to do the math. Remember, for math, chi-squared equals sigma expected minus, observed. This is on the formula sheet, by the way. Over expected. So chi-squared is equal to, we observed 50. The expectation was 27.5 squared over 27.5 plus we observed 40, the expectation was 42.5, all divided by 42.5, plus we observed 10, expectation was 30. So our chi-squared, now we go to the calculator. Please remember to write over here degrees of freedom. There are 3 levels, habitat 1, 2, and 3. So 3 minus 1, so the degrees of freedom are 2. Now we go to the calculator. So I'm going to come over here to my Inspire. Okay, not super visible. Let's see if does this? That's too bright. Let's do this, and let's turn the brightness down. Let's see if I turn the lamp off. Is that helpful? And let me autofocus it. But why don't I zoom in? That will fix things. Okay. So over here we want to punch the data in. So we go into menu. We go home, new document. No, I don't want to save. I'm going to add lists and spreadsheet. Call this the observed. Call this the expected. Observed was 50, 40, 10. Expected was 27.5, 42.5, and 30. Then we go menu, statistics. Nope. Statistics, stat test. GOF, goodness of fit. Observed list was O. Expected was E. Degrees of freedom are 2. Click OK. And there we have our chi-square and our p-value. So the chi-squared is 31. Let's put it here. Chi-squared on the top, 31.894. And the p-value is equal to 1.189 times 10 to the negative 7. Please see the e minus 7. So times 10 to the negative 7. Let me zoom back out. Alright, so this is the math. Now picture. So you want to come up. This is probably not well drawn. Let's redraw it. Come up and now extend it way out here. Here's 31. You want to write df equals 2. Shade all this in. And this is 1.189 times 10 to the minus 7. Alright, and now the conclusion. And the conclusion is, well, the p-value is super small, so since p-value of 1.189 times 10 to the negative 7 is less than alpha, which is 0.05, we reject the null and conclude what is the alternative, that the deer do have a preference for one habitat, or if you want to put it as they did, one food type. You could also have said we conclude that there is statistical significant evidence that the deer do have if you wanted to put the word significant in there, that would be totally fine. So here you go, folks. This is a video of problem number 2.